when we are sorting by start, when we're sorting by end. Also, we'll cover those kind of topic, what is mean merging intervals and what is this overlap intervals. So here, this is the example of what is this intervals. So, for example, it could be like a given time frame. There is like meetings from 9 to 12. And and this is kind of intervals, which is given you as input data. And different ask what needs to be done with them. So usually intervals could be sorted by start time or by end time. Let's figure it out. What is this sorting by start time? Sorting intervals by their start time makes it easy to merge two intervals that are overlapping. So we have these intervals, and they are sorted by start time at this moment. And there is, we will cover this task in depth, how to merge intervals. This is just an example. What does it mean being sorted? This is the timeline usually. And on this timeline, you are sorted your intervals by the start time or by start index. So it's 1, 2, 8, and 50. Is it clear here? Okay.
What do you mean by merging them? Sorry.
Say again?
What do you mean by merging them?
Yeah, I will come. Here will be merging intervals. I will explain what is this, and first I will explain what is overlap intervals, and then we will come to the when we need to sort them by end time, because most of the tasks usually sorted by start time. Okay. So now just quickly we'll cover what is mean overlapping intervals. Maybe it's very basic and understandable just to cover them. So basically, this is our intervals. And this one interval is not overlapping with none of them or with this. But those two intervals are overlapping. What does it mean, overlapping? There is, as you can see, the start date of the second interval is less than end of end of first interval, means they are overlapping. I hope it's clear. Okay, cool. Moving on. What does mean merging intervals? When an interval overlaps with the previous interval in the list of intervals sorted by start time, they can be merged into single intervals. Now that we have those two intervals, we can merge them. This is kind of very popular one ask. So for example, imagine you have interval from our picture, which is, let's say it's A. And then we have B interval, which is 6 and 10. In this case, to merge these intervals, what does it mean? It means that we merge them, and they will be one interval, which is starting at 3 and ending at 10. And there is, to merge an interval into previous interval, we send end time of the previous interval to be the max of either end time. What does it mean? We're always taking the first start, and then we are taking max of end both of intervals. And that's how we will receive our merge interval. No worries about this. There will be task which is focused on merging overlapping intervals. So, and we will use this formula, which is I defined it here. So basically, everything what you need to understand from here, that we're keeping start interval of the earliest one, and we are choosing the max one of the both of the intervals, and we will receive our merge interval. Is it clear? Okay, cool. Now, why we need sorting by end? There is a good example, because sometimes I'm also, there is different tasks. Sometimes you need to sort by start only, most of them, like 80%, which is I saw so far. But sometimes there is quite tricky one, where you need to sort by start and by end, or you can sort by end. And there is, I think this one quite nice explanation in this case. So sometimes imagine that we need to find most non-overlapping intervals. If we sort by start time, we might pick the interval that ends later, blocking many other that could fit into our condition. There is an example. On this picture, I sorted them by start time. Means if we will go in chronological order where we started them by start time, all of these three will be falling down to those one, and we will not find any non-overlapping intervals. But actually, those three are non-overlapping intervals. And to find them, we need, in this case, to sort them by end. So this is the picture which just show you how we sort them by end. We will start from this one. We will compare with this one, whether they are overlapping or not. They are not. And we will find all these three, which is actually not overlapping. And this one is actually overlapping. So this is the idea. How usually during the interview to realize where you need to sort by end or by start. So try to make this visualization. I mean, you can draw and try to sort this way or this way. This is the best way how you can realize whether you need to sort by start or by end. So I believe, yeah.
Lilia, I think it's because of the kind of data there is. Even the first diagram looks sorted by end time, right?
The one? This one?
Yeah, because see, 6, 8, 10, 17, they're coming in order.
Yes, but here you will start from this one because you are starting from 2. You sort them by 2, and in your list where you sorted them, you will start from 2. And you will start comparing those intervals. Then you will start comparing those intervals. And then you will start comparing those intervals. In this case, you sorted them by end time. And this is your first interval in your sorted list. And now from here, you compare them in this order.
Okay. Yeah. I mean, visually it just looks same. That's what I was saying.
Yeah, that's why I put some colors here.
Okay.
And I think I put somewhere here also explanations. Yeah, so this is kind of, I added additional explanation. This is for merging interval, why we are sorting here by start, and if we will sort by end. So we can come back to this one during the merging interval if it wouldn't still clear. But the idea is that you're taking intervals, you sort them either by end or either by start. You will have this object, imagine there is objects, which is intervals, and you will process them in order. Depends how you will sort them. If you sorted them by start, then this one will be your first object. But if you sort them by end, this will be your the last object. Does it make sense now? Yes, no?
Yeah.
Lilia, sorry,
Yeah.
what is the objective here? Like, sorry,
Yeah.
I just missed it. Like,
No
what we're
worries.
trying to do.
Yeah, I'm just trying to explain Moina better. So usually intervals look like this. It's like a object. So we have interval class. So for example, which is defining your, 1 second. Okay, it's, I think it should be like this. So 1 second. No way. So there is like, yeah, you have these variables, which is you introduce. This will be start, and it is will be a like int. So for example, and here will be int end. So this one our object, right? In if we speak in programming language. So we created an object which is calling interval. Now that we have these objects, which is, for example, 4, 6, this one our first object, this one our second object. So, for example, and this our, for example, 2 and 18 object, right? That, is it clear? I'm speaking in terms of object as in using in programming language.
Yes.
Okay, so it means that we here just create the object, which is maybe it's different with any other languages. So it is like new object. And then to process them, we can choose whether we want to sort them by start or by end. So basically, what is the start and end? It's also just, I refer to this index. This is our start index. This is our end index. And when you sort them, the risk could depends on how you sorted them. I will just name this one and this two and this 3 object. So if we go with sorting by start time, it will be our first will be our interval 3. 1 second, and this will be 2, right? No, it will be 1 here, and it will be 2. We sorted them by start now. And after this, once we sorted, we will compare interval 3 with interval 1, right? And we will figure it out that they actually are overlapping. And we will compare interval 1 with interval 2. After this, we will, once is this overlapping, so we will compare 1. We will find out that it is actually overlapping with this one. And we will process this one, depends on conditions. We are not going to compare this one with this one after we process this one, because we know this is overlapping. We will merge them, and we will go and process this one. That's how the start interval here won't work. But if you will start from the end, then you will have a different order here with these object intervals. And you will process in different chronological order based on start. Maybe it's still not clear, but let's cover merging interval, because the rest will also will take decision whether to sort them by start or by end. And the rest of task also. In each task, we will think how we should start.
Lilia, sorry, just one question. So our objective is when we have a different interval, right? So we have to come to a, like a final interval with a starting and the end, right? So in this case, like it will be 2 and 18 because others are all included in that interval. Yeah.
Yes.
So I'm just trying to understand, how does it make a difference if you will choose like a, like by sorting the starting interval, and how it is different by selecting, because at the end the numbers fall in that scope, right? Like you go whichever way, the end result will be 218 because all the numbers like 7, 8 and 4 and 6 are included in that, right?
Yes.
So how does it make a difference? Just trying to understand that part.
Yeah, because you will take intervals, and then you need to move. You will compare first two. Then you need to make decision how you're going to move. You can't take this one and move directly to this one. Usually, we found that it is falling here, and so let me think how to explain better. Maybe this one. But it is. Let's do one thing. I will start explaining these merging intervals. You will see how we're taking decision, how we're moving from one interval to another one. And if
Right.
it will still not clear,
Right.
we will come back.
Okay, perfect. Yeah.
Okay. Okay. So this is our first task. I will share also link on the challenges. And the first one is merging overlapping intervals. So let's cover description first here. As input data, we have input of the intervals. So there is no, and return the result merge intervals. Merge of the intervals, so there is no overlapping intervals. And return the result merge intervals. So we have input of intervals, and we need to figure it out whether they there is overlapping intervals, and if there is overlapping intervals, then we are merging them. So in this case, if you see, we have 1 and 4, which is overlapping with 2 and 5, and which is overlapping with 3 and 4. We are merging them in one interval, which is 1 and 5. And next, we have 6 and 7, and 7 and 8, which is also following overlapping intervals, and we're merging them, and we return 6 and 8. So this is the whole ask. We have input of intervals, and we need to find if there is overlapping intervals, and if there is overlapping intervals, we need to merge them. This is clear description. Okay, cool. So there is 2 main challenges. Identify, find first overlapping intervals, and then merge those intervals. So let's start first by, okay, intervals start before P, below, as we discussed, what is this non-overlapping and what is the overlapping intervals. Again, this one not non-overlapping intervals, and this one overlapping intervals, even though it is end and start at 5, but we are considering them as they overlapping intervals in this case. But sometimes during the interview, you can ask whether we should include and if we should count them as an overlapping intervals. It's usually it is, but it's usually something which is you should ask before. Yes. So in this task, those kind of intervals are overlapping. As another example, what is the overlapping intervals? So based on these 3 examples, we can establish cases. Before. So if I end less than B start, then it's not overlapping. Here we have our end. 1 second. We will compare how we have found who is overlapping and who is not. And this will be B start. So we in this case, our end is less than B start. And in next cases, here, it is equals. And here, 1 second. Our end start is actually bigger than B start. So that's how we can find, identify who is overlapping, who is not. Means if I end less than B start, the interval do not overlap. But if A ends and B start, A end is bigger or equal, then it's overlapping. So we identify 2 conditions. And with above logic in mind, now we can try and find overlapping intervals. After we will find our overlapping intervals, we need to merge them. As I described here, we will use this formula, we will take dot start, but our new end will be the maximum of our two intervals. Okay, let's go and consider this as an example. The first step is to sort these intervals by start value. In these cases, when we are merging intervals, we are sorting them by start. Next, we will come back why it is important here to sort by start, not by end. I found another example where you can see the difference. First, let's just cover why by start and task, and then we'll come back to the why it's a better idea to sort them by end. So with the above logic in mind, let's tackle an example. Consider the following intervals. So we sorted them by start. Here we have our time intervals. This will be our first interval, second and third. So basically, at the beginning, we will take our first interval as already one which is ready. So we take the very first interval, this one, and we will this will be our A interval here. Next interval our will be B interval. We will compare the end and start. This is clear now that we took our input, which is not sorted. We sorted them. We choose our interval, which is under 0 index. We call them A, and the next interval we're calling B. And now we are applying our conditions, which is we defined here, to find out if they are overlapping or not. Is it clear till now? Okay, cool. So once we will found, I need to remove this cursor fox. So now, so we are merging. We identified that they overlap. We are merging. What does it mean, merging here? We apply this formula. We take A start. We found max B. We found max out of these two intervals, and we choose one. In this case, B ending later. So we will have at the end of this operation a new interval, which is we merge it. So this is our new A interval, which is starting at 1 as the one before, and it's ending at 5. So now we're working this is our A interval, and we're jumping to the new B interval. This is out. These two intervals out because we make the operation. We found out that they are overlapping, and we merge them. Now, because we sorted them in chronological order, this is the third interval. Now we're checking them with the third one. We are checking if the A end is bigger than B start. So it is overlapped, yes, because this is our A end. It's definitely bigger than B start. It's also, be very careful. We're taking A end and we compare B start, not B end in this case. But when we are merging, so it is overlapping. When we are merging them, we take the opposite. We take A start and we are compare the ends here. So in this case, end is bigger. So it is falling down under our overlap intervals. So this 3 is now out. We have our A start interval, new one, which just didn't change because this one is shorter and it didn't change our A start and A end. Now we're moving to another one, which is B start. Here it is not overlapping. So is it not overlapping here? We are moving now. We are leaving this interval. It's no longer our A interval. Now our new A interval is this one. Which one was before? So if it's not overlapping, we're just not merging them and not applying. We just coming back to the B start here. Now that we are compare B start, we're moving to this interval. And now come back, folks. I apologize. I think it's a good time to come back to this one explanation. Now that when asking about non-overlapping intervals, you can see if we will start from this one, we make this operation with this one. We will consider that it is overlapping. We will skip it. Then we will move to this one. It is again overlapping. We will consider this one. Again, it is overlapping. And we won't find anyone which is not overlapping if we will apply this logic. So now, if we are sorting them by end, as I explained this one, this different chronological order. Now we will compare this one and this one, and we will have a variable which is will track non-overlapping intervals. We will count these three, we will found, and this one actually will be an overlap with this one, and we will not count it. So I hope it's clear. If it's not still clear, we can continue. How do you feel, folks?
I have one quick question, but why do we? Are you saying that for this particular problem, where we are supposed to give a final array of overlapped intervals, do we have to check non-overlapping anywhere?
In these merging intervals?
Yeah.
No, here you are particular, you ask merge overlapping intervals. Here, merge means when someone asks you merge overlapping intervals, you need find overlapping intervals first and then merge them. So you don't care about non-overlap. Well, you care about this because you don't need, you don't have to merge them. You should recognize who is overlapping, who is not. In this case, see, we reached to the point where we found where we found that A start is not overlapping with B. In this case, what we are doing, we left these A intervals here behind, and we move to the one which is B. And now it is A, because we know we sort them by start. And there is no other intervals which will be overlapping with our A start, which will be any time after this point. What I mean? After this point, there is no intervals which will be overlapping with A intervals anymore. That's why we are moving to this interval now. And this one will our new A intervals. Does it make sense? Because we sorted them by start time.
Right. Yeah.
So this is give our confidence that now we process all the intervals, which could be overlapping with initial A. And once we reach to the point where there is no overlapping, we are moving to the, we are calling a new interval, our A interval, and we are processing them already with this one. This is the idea, to find the right things, how we should sort them by start or by end.
Okay, that makes sense, yeah.
Okay, so now that we're confident here on this place, we are moving this our A intervals. We are compare those one, B and A. Now we have this A and they are overlapping. They are starting at the same and ending at the same time. So we are merging them and we receive a new one. So basically, that's it about how we are merging and that's it about this task. This is the code. So let me go with Java. So first we will take these intervals. We will sort them by start. Here I'm saying explicitly that I want to sort them by start. Next, we are creating a new list which is will be our output, our answer. At the beginning, before looping around all of these intervals, we are saying that our first interval will be as a part of this list. And now we will start our loop from the second interval. Here, we're taking this one. It's maybe better to, it will be our A, it will be our B intervals. Here will be our 8, and here will be our B. And here we are saying our A, and here will be our A, and here will be our B. And here will be our B. When there is no overlapping, we're just putting them. As a we are just putting next interval, and now we are starting our iteration. This our new first A. See, if we found no overlapping intervals, we are putting B, and on the next iteration it will be our new A, and we will process with the next one, which is will be B. Does it make sense, folks? Feel free to ask any questions. We have not that many to cover today, so we have a lot of time. Okay, let's try again to come back to why it will be as a bad idea to sort them by end if we will start sorting by the end. So I took the another example because with this example it's not really workable. So if we take this one, the tricky one, input, and we're sorting them by end. This our list will be looks like this with the intervals. But if we will sorting them by start, it will be looks like this. Now let's process by the end. So we take our 2 and 3. We're checking it with 4 and 5. It's not overlapping. We're moving on. Then we are taking 6 and 7. It's again not overlapping. We're putting them into list like not overlapping. Then we find 8 and 9, and we're putting them 8 and 9, and it is also not overlapping. And in this case, once we reach 1 and 10, we realize that okay, this is overlapping. We're doing merging, but we already has this array, these intervals in our list, which is wrong answer, right? Because all of them are actually falling down to this one. At the end, it should be only this one interval. So this is how important to realize how to sort by end or by start. Is it clear on this example?
I have one question. Like the code, and this is very clear, but only one thing which I'm not able to understand, how to make the judgment. I mean, this time we have the data, so we can make the judgment by checking the data. But from code perspective, how we can make the judgment whether we should sort by start or end?
So as I mentioned before, it is tricky one. It is required to once. So it is with practice. You will start practicing, and approximately you will realize at some point where you need to sort by start, by end. But at the beginning, where you just start to tackle this issue, try to draw for yourself a timeline. Sort them first by start, sort them second by end, and then you will figure it out what tactic will work. So for example, we will start from the start, right? Like in this example. You sorted them by end and you sorted by start. And try to make the dry run, how you will iterate over the intervals, and whether you will lose or you won't lose them. So sort by end, try to figure it out whether you won't lose anything, and then sort by start and see if you actually will be able to find overlapping intervals by start, or if you will able to find them overlapping by end. So this is only the way to go. There is you can learn this by heart. I mean, you can solve a lot of tasks, and just to remember, okay, in the task where there is emerging intervals, I remember there was start, but this is not the way. So try, once you will take the task, just try to draw it on the paper and decide for yourself. Is it start or is it end?
Okay. Okay, I understand, but when we actually submit any coding stuff on the HackerRank or somewhere else, so they have multiple inputs, like multiple test case. Every test case have a different input. So should we assume that if the example which is given in the statement, if that worked with sorting with the start, then all the test case will pass based on the same approach?
Where you have different inputs. You mean different inputs in the
Yeah, I mean, when we submit things on the HackerRank, so we have different, like multiple test cases we need to run on LeetCode. Sometimes it's like 200 test cases. So
Yes.
can we say whatever mentioned in the program, in the problem statement, if the problem statement solved easily with sorting by start, then all the test case will also follow the same process?
Yes, this is regardless of the input, right? It is algorithm which is you are choosing how to solve. So basically, everything what you should be focused on during the task, that you found description, as we discussed now, description, and now we figured out what needs to be done. First, we need to find overlapping intervals and then merge them. So that's how your thinking process should be. You're reading, regardless what is this input given. First, trying to overlapping intervals. Once you found overlapping intervals, just merge them. That's it. And it should cover all the inputs. This is regardless of the inputs. We will cover two more. Probably it will add more sense.
Yeah.
Hi, Lilia.
Thank you.
Hi, Lilia. So can I just clarify as well? And I think I'm sort of following on from Mansi, really. What you're saying is, in some task descriptions, it's better to sort by start and others sort by end. It's not particular to the data you're using, it's the actual task description. But what you're saying is, dry run with some data and it'll work out whether it's start or end. It's not particular to the data that you're being given.
Yes, it is regardless of the input. You're choosing algorithm. And once you choose the right one, algorithm, it should work with all the inputs. It is not on the description. From the description, you are trying to understand what needs to be done. From this description, we know that we need to find if there is any overlapping intervals, and then we just need to merge. So basically, to take decision whether we need to sort them by start or by end, it is the first one. For this one, you will just make kind of this paperwork. I mean, you will draw some intervals. You will try to find out. So you will play like I put this example. There is a different sorting order. There is the chronological. So if you sort them by start, it will looks like this. If you sort them by end, it will be processing looks like this. So to sum up, input data, the input data is just for you. So it is regardless of the input data. It is about the algorithm which is you need to create and to apply to this task in order to satisfy all the inputs. But in order to find this algorithm, you just thinking what needs to be done, and then you're trying to solve how to better to solve. I have these intervals. It's usually, once you have task on the intervals, it's usually about to find the right way. If I'm sorting them by start or I'm sorting them by end. Sometimes we are sorting by both, start and end. I know it's very tricky and probably it's a bit frustrating that there is no clear answer which is I can give you and tell that, okay, folks, this task is for sorting them by start. This is by end. No, it will come from the practice. That make this practice better. Take a task, visualize it, and then you will gain this confidence. So yeah, I hope it makes sense. And as I try in this time, I sorted by start. Then I try to show you the proof why it's a bad idea to sort them by end. That's how you should start thinking. So let's moving on then to the next one. In this case, we are again trying to find overlaps intervals. But in this case, we need to find intersections of these intervals. And it's slightly different. Now we have as an input two sets of intervals. And in each set, there is no overlapping intervals. In set 1, there is intervals, but they are not intersect. In the second one, there is also a list of the intervals, which is not intersect. And they are sorted already for us by start value in this case. So the ask is to find where these sets are actually intersect. So in our case, so for example, we're taking first interval from the first set, 1 and 4, and we are comparing it with 2 and 7. And when we found out that they actually intersect in this time frame. So starting from 2 and ending at 4. Next, we will take 5 and 6, and we actually will take decision. We will move. We will compare 2 and 7 with 5 and 6 in this example, and we will find that they intersect at 5 and 6. Next, we will take this 5 and 6, and we will try to find if they intersect with each other. If they not, then we're moving, and we are comparing those two intervals, and we find intersection time. I will cover this in depth, how we're taking decision, how we are moving from one interval but to the another. So this is just description. We are giving two sets of the intervals. In each of these sets, they are sorted already by start value, and they not intersect with each other. The idea of this task to find where these sets are actually intersects with each other. Is it clear from the description?
Just one thing. So here we are comparing 1, 4 with 2, 7, like first
Okay.
indexes of both intervals.
Mm-hmm.
So the merged one should be like, I thought it should be 1, 7.
Say again? No, intersection. We are looking intersection here.
Okay, sorry. Yeah, now I got it. Sorry.
It's fine. Yeah, intersection. There is. We are not merging them. This is another ask. So we are find intersection between them where they are overlapping. So this is the idea, not to merge them, just to find the time frame where they are overlapping between each other. So okay, this is the intuition. So basically, I explain it on the example how we are moving. Now let's identify the overlap between two overlapping intervals. It will be the same like we did in previous task. So it's the same. Again, we will take, we will have our A interval, we will have our B interval. We will compare A and B the same way as we did in our previous task. The difference only that now we are not in the one list of the intervals. We are not putting them into one list. We will take this. This will be our, for example, A interval at the first place, and this will be our B. And the same way, we will try to find whether there is overlaps between them, because we need to find overlap intervals. So it is stay the same as it was before. Is it clear at this point? Okay, cool. Now we have another challenges here. In previous task, we have we had to merge these intervals, but now we need to extract the overlap between these two overlapping intervals, which is we're calling intersection. So the overlap just be the overlap ends in the earliest in the points. Okay. Now we need to define another formula. Let me just to explain what intersection here will be. This will be our 1 and 4. And here will be our 2 and 7. So this we need to find intersection here. So intersection will be 2 and 4 here. It is not we are not merging intervals. If we will merge them, it will be 1 and 7. How we will find this intersection? Now we're just defining the formula which is we want to apply once we will find overlapping intervals. So we need to take instead of A start, in this case, we will take B start because it's intersects here, see? I will explain. So assume currently that we have A, which is always A start, which is always will be earlier than B start. Because in the task here, we always will choose who is our A and who is our B. At the beginning of the task, it was told that we have in the sorted order all our intervals in the set. At the beginning, we don't know who is A and who is start in this task, but we will always figuring out, based on this formula, who is our A and who is our B. For now, just assume that all the time we know that A is started earlier than B. And with this knowledge in hand, so we can identify the formula how we will find the intersection of these both intervals. It will be our B start here, and instead of find the max, as we did for merging interval, we will looking for mean end. That will be our intersection of those two intervals. This is the two main points. So I took the task. I read the descriptions that we need to find first again overlapping intervals. We will follow the same formula. We will compare our A end and B start. Once I will find my overlapping intervals, now I need, instead of merging them, I need to find the intersection of them. Here I defined the formula how I will find the intersection of these intervals. That's how I will build my output. So description, what needs to be done, and now let's put it into actions.
One question, Lydia. How did you choose? So how did you choose which one was B? Because before deciding the minimum of A end and B end, you have to choose the B, right? Can you explain that again?
Yeah, that's where coming to here. It's this is the right question. This is the the main point of this task. Now, if you will see here, I define it. It's ing. We at this point we don't know who is our A and who is our B at this point. Let's start by considering the first interval from each array. To set A to the interval that start first and B to the interval, we will use this condition. So at each point, we will take intervals, and this our from our set from set 1, we will take first interval, and we will compare with the first interval from the set 2. What we need to compare if interval starts. So basically, if the interval A start first, then it will be our A. If the interval G start first, then this one will be our interval, A. So we're just comparing the start time of two intervals. And we name them, depends on the start of those intervals. We will figuring out who is A, who is B. A always should be one which start earlier. Does it make sense here? Okay.
Yeah.
Yeah, cool. So this is a part of our code. First, we need to find who is A, who is B. Then we are checking intervals A and B actually is overlapping or not. In this case, they are overlapping. We found our first intersection interval. It's 2 and 4. Now we need to decide where we're moving A and G, because here we found our first intersection with these intervals, and now we need to figure it out which one we are going to process. Should be it's E or G. In order to identify them, we are checking who is ends. In this case, A already ended, but G is still continuing. Means we found this intersection, and this one is not going to overlap with none of them. And we take decision that we're moving to the second interval, which is A, and we will to the second interval, which is A, and this will remain the same because it's still active. It's not finished one, and there is probably will be another interval which will actually intersect with the J1. How we decided? So yeah, won't overlap with any So basically that's what I just told. More intervals from the intervals. So let's increment interval one pointer E to make the next interval in the array. We will compare the ends. Who is earlier ended, it's falling out. And who is still active and continue, we will keep it, because there is possibly another interval which will be overlapping with this one. Is it clear?
I have a question here. I didn't understand why we're moving to the next interval, because we already found an intersection in the first I and J, right? So that is one result, isn't it?
Yes.
Because what happens is, if we keep having intersections along intervals 1 and 2, which means that, for example, assume that I is longer than, second I is longer than J. So you know that second I that we moved to, let's say that is longer than J. So what are you going to do then?
This one will be longer.
Yeah, it ends after J.
It's an so let's draw it. 1 second. So if it's ending here, right?
Yeah.
So then for the second one, and let's put it this way, it's end here. See, we have two sets here. 1 second. How to? These two different sets, which are sorted by start value. Now, if you see, we compare, we take this one, which is you're saying this one is longer, right?
Yeah.
But this one is already ended, right? And we know because this set is containing non-overlapping intervals and sorted by start, means it's already ended. And as you see on this visualization, there is no other intervals which could potentially intersect with this one. Thus, we're taking decision to make our next, this will be our next J here, and this one will still remain A. Now we will process this interval with this interval.
So my question is, so at which point are you actually deciding the intersection? Because as we keep shifting I's and J's like this, where do you say, okay, I have found one intersection and I'm going to store that?
Yeah, you will process each intervals against the another intervals all the time. So we started from this one intervals and this one interval. We found that those two intervals are actually overlapping. They are overlapping here and here, right? We process them. Now we put into our output solution 2 and 4, and now we know. Now we need to move further in order to compare other intervals, whether there is intersection. In order to take this decision, you can look at these timelines with the intervals. You see that this intervals is already will be finished somewhere here, but this one is still continuing. Means we need to move to the second interval in the set one, because the first one is already finished. We found intersection, but this one is still continuing. We found intersection between them two. It is over here, means there is if it's over, there is no other intervals. But if here will be, so for example, if instead of here will be a shorter interval like this, then you can see, and here we will put another one interval, for example. Then which we should, so we compare this and this. See?
Yeah.
And it is ended here. And you can see from the visualization that we need to keep this interval. But because there is another will be interval in the set 2, which is we can still find another one intersection. Does it make sense?
Yeah, it makes sense. Thank you.
Okay, cool.
Just one question. If end of both I and j are equal, then we will move both pointers, right?
No, we will keep still, but just 1 second. If there is, let me see.
And if ends of both equal, then no one continues further.
Makes sense
So we
to
will
move them together. Yeah. It's definitely, yeah. Then we will move. But I believe in this condition, in this task, I didn't put it this way. But I believe, yeah. Advanced pointer. Let me see. If it's end and it's end, advanced pointer set with the intervals that end. If interval is end, then we advancing 1, and then we're advancing the G. But actually, yes, it makes sense to have here the third condition, which is if they both equal, then we're advancing 2 pointers at the time. No, see, if intervals end, we're advancing, yeah. It makes sense to put the third condition here.
I mean, this is also covering that condition, but then we need to maybe do the iteration in the if condition. This will not fulfill. That will definitely cover. But yeah, if we put that condition, maybe we can skip 1 or 2 comparison. Maybe. Yeah.
Yes. That's a good question. Yeah. So basically, yeah, if they ended at the same time, so we are advancing both of them. Okay, so yeah, basically, this is just summing up what we have discussed so far. That at the beginning, we need to find out who is our A and who is our B. Then we need to find out if these intervals are actually overlapping. If they are overlapping, then we find our intersection. We put our output, and then whichever interval ends first, advance its corresponding pointer to the move to the next interval. So, and this is the actual implementation. So we will starting, we have our 2 sets of intervals. we are setting ANG at the 0. We are entering into the loop. We are choosing the who is our A and who is our B, depends on the start time. Then we're checking if they are actually overlapping or not. Once we found if they are overlapping, then we are setting our then we found intersection, which is we're building, and here we are deciding who we are going to advance next. Yes, depends on the end, but there could be the third condition where we're advancing both them. Does it make sense, folks? Okay, cool. So basically, in this example of the intervals, we are not sorting by start or by end. It was sorted for us at the beginning by start value. So in this task, we just need to figure it out who's overlapping. And then instead of merging, we are tracking intersection. The tricky part here, how we are going to advance our pointers here. So, okay. If there is no questions, then let's move to the third one. No questions. Okay. So largest overlap of intervals. Given an array of intervals, determine the maximum number of intervals that overlap at any point. Each interval is half open, meaning it includes the start point but exclude the end point. Exclude endpoint. I will explain what does mean on this example. So you have input of the intervals. You need to find all active intervals. How many intervals we have at the same point, which is overlapping. So in this case, we have free one, this one, and this one. What does that mean? But exclude the endpoint. In this case, if you see, there is end and start is intersect. But we are not saying that this one is actually overlapping with this one. So overlapping only those three elements. This one is not included in our output.
But isn't that 6 to 7 overlapping with the top two?
We need to find intersects. Yeah, it is true as well. So this one and this one, it also having the active point as well. It will be also free. So it will also give the same answer. I mean, we need to find the maximum number of intervals overlaps. Yes, it could be either this one answer, or it could be either this one answer.
Right.
Yeah. Okay. The description is clear at this moment. We just need to find maximum number of intervals.
So when we say half open, does it mean we don't compare? I don't understand exactly what half open meant.
Includes the start point but exclude the end points. This means that those two are not really overlapping here. Because we will take this one where they actually is overlapping, it will be somewhere here. But if we will include, means will be 4 at this point. But the statement is state that but exclude the endpoints. So we're excluding this one. It's not really overlapping with this start one.
Yeah, okay.
So to find the number of active intervals at any point in time, we need to identify when interval has started and when interval has ended. The start point of intervals indicate the start of new active intervals, whereas end point represent an active interval is finished. This suggests an approach which we will track our start and end of each interval in order to find out who is how many intervals at the same time is currently active. So I will explain. Let's take this example. We will start from first interval here. They are not sorted also, folks, here. There is no sort by end or by start. We are not sorting them here at the first. So we have currently we're just trying to find trying to think how we are going to find active intervals at the same time, the maximum active intervals at the same time. So here we will take this interval, which is our I. At this point, we will start to count. We will introduce active intervals variable, and we will start. Once I, here it's starting our point, we know at the same time we have one active intervals. We increase these active intervals by 1. Next, we're moving to the next interval. Now we see it started here. We'll increment it, and we know that at this same time we have 2 active intervals, which is intersects. I mean, they intersect and they are active. At this point, we have a maximum 2 active intervals. Now we move here. We know this interval is actually ended. What we're doing here, we are taking active intervals and we are decremented. Now we know there is only one interval which is at this point is active. And that's how we will move to the, 1 second, is in point, which means an active interval has finished. So let's decrement. Now the number of active is 1 corresponding. We now rationalize we need to do whenever we encounter the start point or end point. So based on this rationality, currently we determine that we will track active intervals based on start point and end points. Means we need to track those 2 points, and start and end. We can rely only on start value. So what I'm trying to say in this case, it won't be just enough to sort them by start, but we need to track both in chronological order, start and end point. Yes. Is it clear now? I believe not really. Right? Ask questions, folks.
So when we started this ing, I mean just I, what did we already sort this in the according to the start point or the end point?
Yeah, this the different type of algorithm. Let me
Called the line sweep algorithm, right?
Yes, because it's not clear from the how we are come to this point. Let me just think how better to explain it. I'm thinking how to this the idea of this task. It could be solved as well. I mean, no. In this task, you anyway need to sort by start and by end. But this is the specific algorithm which is calling which is calling sweeping algorithm, sweeping line algorithm. In this case, what we are doing, we are sorting everything, and sort and start and end into chronological order. So as you see, we took all the intervals. We took start and end, and we put everything in the chronological order in order just to keep track how many active intervals is here. How we are doing this, I tried to explain from here. Once we will, and we know who is start and who is actually end intervals. So once we put them all in the list, we know we will put identification, whether it's start or end, and we will start to track on each start and points, because it's a signal about that there is one intervals which is already started. And if it's ended, means there is intervals is actually ended. And we are removing from the active. That's how we're going to track in this case. All the intervals which is at any point of time are actually active. So let me think. So we track start. We can apply the same algorithm with intersection, which is we discussed previous, or with merging interval, where we just looking for overlapping intervals like we did before. It will perfectly work here as well. Just to know, just to find at each time any overlapping intervals at the same point of time. But there is another algorithm which is exists, and it is a little bit standing out of the algorithms which we discussed so far before, and it's calling sweeping line algorithm. Now I think I'm a little bit confusing you folks.
I think I'm understanding what you're saying. You're saying that the other two approaches we used will work
here.
100%.
Mm-hmm.
Yeah, but if we use this sweep line algorithm, basically you take all the endpoint start points, sort them, and then every time you encounter a start point, you increment, and you encounter an end point, you decrement. And so my question is, when we finish this, is active intervals the final answer?
Yes,
Okay.
because we will track. Do you remember we discussed last time when we also were introducing max value? And each time, after each iteration, we will compare whether the previous answer is actually bigger than the one which is we're ending up now. So at each iteration, we will just track our max overlap intervals.
So when we iterate, are we iterating through the array list that is sorted, or are we iterating over a map? I didn't follow that.
Yes, we will iterating over these points.
But how do you know from those points which one is a start point and which one is a end point? Because it just looks like a plain list of integers, isn't it?
No, it will be our map here.
Map.
So we will have start, and you will have S. So you will sort them based on the key value here. And once you will take the first one, you will see if it's S, means it's start, then we will increment our active interval. If it's not, then we should decrement this one. And then we will compare whether our max needs to be updated with new active intervals. If it's bigger, then we're updating. If it's not, then we're keeping what we have ever seen. So yeah, this is a little bit standing out of the other approaches, but the approaches which I explained before, it could be mapped to this task as well. So because you need just to find all the overlapping intervals at the same time, and instead of creating a hash map here, you just will using the same formula which is we're having here to find if it's overlapping or not, like A and B start. If they are overlapping, we will increment our max interval, our active interval, and then we will just compare here. So this, yeah, so both approaches will work here. But this one, another one algorithm, which is falling down under intervals pattern, and which is calling a sweeping line algorithm. Me personally, I never use it in the interview. I usually apply the one which is I described before, with overlapping intervals and sorted based on start or by end. But this one, I opened it also recently when I was preparing this material. But I think it's a cool one. It could be applied. Yeah.
I got this particular one for an interview.
Again?
I got this exact algorithm for an interview.
Mhm.
What they asked, it's the same thing, except that the problem was looking like, okay, tell us how many maximum overlapping calls. So they created like a timestamps, right? So
Yes.
they wanted to say, find the answer of how many maximum calls in that day were overlapping. So the calls were start time and end time, which were given epoch timestamps. And they said, okay, tell us how many maximum overlapping calls were there for each day in that month. So it at the end I had to use this, but yeah, I didn't do it quite well. I have one last question. When we are incrementing and decrementing active intervals, can you just scroll up? I just want to see the line. Yeah, no, the line graph. Yeah, this one. So over here, let's say none of the calls were none of these points were overlapping. So there is one start, one end. So will there be any point in such a case where active intervals will be 0?
Let's check the description. Given an interval, determine the maximum number intervals that overlap at any point. Each interval is held. I got your question. Let's think. So you're basically asking if there will be intervals.
Yeah. So if we have one like that last one
And
there.
this will be one. And what will happen here at this point?
Yeah.
As these all intervals will be finished, right? Here will be finished one. And at this point, before you will jump to this interval, you will have active intervals, which is 0.
Okay.
And once you will finish, find this interval, you will increment, it will be 1. But because of this, two intervals are not really intersect with each other, and they're not overlapping with each other. Means here you again, your active intervals will be 0. And once you will start with this interval, it will be 1.
Okay.
Yeah.
Thank you.
Nope. So the idea is to put all these things into a map, to track, to sort them, all of them, end and start, to put in the same map, to sort them chronologically, and keep track who is start, who is end. There is one edge case, which is we need to discuss. Okay. This edge case, processing concurrent start and end points. This is an edge case about when we should increment active or we should decrement, and which order we should increment on or decrement this task. So if we will, so for example, we process start point, our active intervals, we will figure it out that first we will start from starting point. I'm speaking about these things. Let me adjust to show what exactly I'm speaking about. I'm speaking about this one part. This is our edge case here. So assume you will have, and there is this one, our end, our 6 here. And there is our start, which is 6. So we should decide which order in map it should be. It should be first come end point, or first should come start point. Does it make sense now what I'm thinking about the edge case? Okay, so here we need to figure it out how we should processing. If here we will put first our start at 6 and only after all we will put end, means we will increment and we will put it and our active intervals will be 4 here, which is not right. Means the order should be this way. It should be first end and then start. This is the edge case in this task, which is in this task, which is we should encounter. So we should first process end intervals and then start intervals.
But what difference will it make? Because whether you increment first, you decrement immediately, right? And then, but if you decrement first, then you increment immediately. I mean, actually, if you actually have end first, you decrement and then you increment, correct?
This is the order which is we should follow. This is the order. So first we need to decrement and then we should increment. Otherwise, if we see here, if we will put first 6 here and it will be our starting point here, then at this time our active intervals will be equal 4. Oh, equal 4. Means here we will update our answer that we are so 4. And on next iteration, you only decrement it and it will be free, which is not right.
Okay. Because we are taking a max in the next step. Okay.
Yes. So basically, you should sort first by value, and then you also should sort by end and start. That in your case, it will be on this one order. So basically, that's it about this task. Any questions, folks, so far? In the homework, all of them you just need to cover. I can post on the Slack all the tasks which is falling to the this sweeping line algorithm. Yeah, you can practice. For me, it's something which is I opened for myself as well while I was preparing this material, and I didn't really know whether I should put it in order to not confuse you. But then I decided why I will keep this algorithm from people and decided anyway to cover it. So.
Lilia, do you have time for a quick question, if you don't mind? That last task you mentioned, you can do both